Matter in our surroundings.
Today's date? Once again, good morning, everybody. Welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class, we were discussing the chapter Matter in our Surroundings. In this chapter, we were discussing the concept called the interconversion of different states of matter. We all know that one state of matter can be converted into another state by two methods, either by heating or by cooling. Either by heating or by cooling. And could you tell which two physical quantities are responsible for changing the state of matter? One is temperature, second one is pressure. One is temperature, second one is pressure. So these are the two important physical quantities by which we'll change the state of matter from one to other. And even we have also come to know the processes that are involved during the change in physical state of a substance from one to other. Is it not? Then if so, could you tell the change of physical state of a substance from solid to liquid?
Melting.
It is called melting. It is also called fusion. Then liquid to gas. What it is called? It is vaporization. Is it not? Then a process that takes place during the conversion from liquid to gas with bubbles. What it is called? Boiling. Then what is called the physical change in physical state of a substance from gas to liquid? It is called condensation, right? Then liquid to solid, it is called freezing. It is also called solidification. Then what is called the change of physical state of a substance from solid to directly from solid to gas? It is called sublimation. Then gas to solid, that is also called sublimation. Now, could you tell, will there be any change in the temperature when a solid starts melting? Will there be any change in the temperature when the solid start melting? Solid melt ಆಗ್ತಾ ಇರುತ್ತಪ್ಪ. Temperature ಏನೋ change ಆಗುತ್ತಾ? No, there will be no change in the temperature. And what do you call that constant temperature? One definition ಹೇಳಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. What do you call the specific temperature at which solid starts melting? Melting point, right? Then what do you call the specific temperature at which a liquid starts boiling? It is called boiling point. Prashant sir, you may unmute the students.
Sir, unmute sir. Unmute yourself, sir.
Ane nimage allow ಮಾಡಿದ್ದೀನಿ. You are reminding me. Okay. Listen. Then what do you call the specific temperature at which liquid starts freezing?
Freezing point.
Freezing point.
Then in addition with that, even we have also come across some other terms like what do you call the substance that undergoes sublimation?
Sublime.
Right. And what do you call the substance which is obtained as a result of sublimation?
Sublimate.
Got it? Then Amulya CK, give any two examples for sublime.
Camphor and naphthalene ball.
Very good. Camphor and naphthalene bonds. Kia. Any other?
Ammonia.
Sir,
Ammonium chloride.
Very good.
Ammonium
It
chloride.
is ammonium chloride. What is the chemical formula of ammonium chloride? Wait. Here I'm asking. Good girl. Yes. Sit tight. Yes. Dhanush is correct. Don't know. Very good. Lavanya, what is the chemical formula of ammonium chloride?
NH4Cl.
Wait. I'm giving Chetan or else Aniket.
NH4Cl, sir.
NH4Cl.
Very good. It is NH4Cl. Ammonium chloride. Please do remember this chemical formula. Don't write. Okay. Even I've given you the information that what are the changes which will be taking place inside the matter when it is being converted from one state to another state, right? When the solid is being converted to liquid, inside solid, the changes that we can observe are, one is the temperature of the substance increases, then kinetic energy of the kinetic energy, we will go for using a vibration of the particles increases. Due to this, they try to overcome the force of attraction acting between them. As a result of it, they move away from their positions. Intermolecular space increases. At one stage, it gets converted into liquid or it starts melting. So this is how solid is converted into liquid. Similarly, while converting from liquid to gas, whether heat should be given or it should be removed.
It should be given.
Right. When heat is given to the liquid, what do you say about the temperature? Temperature obviously increases. And the energy of the particles, that also
Move faster.
increases. Intermolecular force
Decreases.
intermolecular space
Decreases.
got it. At one stage, these particles will become the particles of gas. They start moving freely. So this is how liquid is converted into gas. Like that, even we have come to know other conversions as well. Then after discussing all these, then I was giving you some points, right? What was the last point? Please give your
Sir, terms. Sir, boiling point.
boiling point. First one, melting.
Boiling
Second
point,
one,
sir.
melting point.
Boiling point, sir.
Next, boiling. Afterwards, boiling point. Now we are moving to the next term after boiling, which is vaporization. Right?
Vaporizing.
Fifth term, vaporization. Fifth term, vaporization. Yes. Written up. Write the definition. How do you write? The process of change of physical state of a substance from liquid to gas on heating or cooling. On heating. Right. Yes, from liquid to gas. Just to show this one. Right. Definition. The process of change of physical state of a substance. So should go on writing with me. The process of change of physical state of a substance. From liquid to gas. On heating is called vaporization. When the liquid is being converted into gas, will there be any change in the temperature?
Yes, sir.
No, yes, sir.
No, there will be
No, sir.
no change in the temperature. All liquid to gas age convert ಆಗೋ ತನಕ temperature ಹಂಗೆ ಇರುತ್ತೆ. Got it? Because the temperature of boiling point, alva, it is over. Next, sixth term. Liquid to gas ಆಯ್ತು, gas to liquid.
Sublimation.
Freezing point.
Condensation, right? Condensation. Go on writing with me. Same also. The process of change of physical state of a substance. Gaurav, repeated I have been telling. Please go on writing with me. The process of change of physical state of a substance. Process of change of physical state of a substance. State of a substance. From gas to liquid.
On heating.
Yes, gas to liquid. On cooling.
Is
Called
condensation.
condensation. During condensation, that is, during the conversion of the substance from gas to liquid, whether heat is being removed from the substance or heat is absorbed.
Heat is absorbed.
It is observed. It is removed, sir. Removed.
Yeah, when the cup of water is taken and is kept in the freezer section, then the heat present in the water will go on. Is gone
Decreasing.
removing. So that is why the particles will start coming to close to each other and it becomes ice. So heat is released, it is given out in case of condensation process. Right. Next, seventh one. What do you call conversion from liquid to solid?
Freezing.
Purification.
Solidification.
Freezing.
Solidification. Amog, are you following? I'm okay. Right. Next, freezing. Solidification. Freezing or solidification. Dhanush, can you see from there? Or else you may see from here. Right. The process of change of physical state of a substance. Physical state of a substance. From liquid to
Gas. Sorry, solid.
liquid to solid. On cooling or
On
heating?
cooling. On cooling.
Cooling, sir.
On cooling is called
Freezing.
freezing. Better now?
Yes, sir. Yes, sir.
what do you call the temperature at which the liquid
Freezing
starts
point.
freezing?
Zero
Freezing
degrees.
point.
Freezing.
Called
0
freezing
degrees
point.
Celsius. 0
Freezing
degrees
point
Celsius.
of water is 0 degrees
0
Celsius.
degrees Celsius.
And it will be differ from 1 to 1. Right? 8 means freezing point. Freezing point. Yes. Amok BM. Tell the definition quickly. Freezing point definition.
The process of change of physical state of a substance from
I'm asking freezing point.
So the
Specific
temperature at which
temperature at
the
which
temperature at
liquid starts
Changes
freezing.
freezing
changes
into
from
solid.
physical state
Very
from liquid to
good.
solid is called freezing.
Myself only will tell. The specific temperature or a definite temperature at which liquid starts freezing is called freezing point. Right up. The specific temperature or definite temperature. The specific temperature at which liquid start freezing. Freezing is called freezing point. Freezing point. In bracket you may write FP. Melting point is abbreviated as MP. Boiling point is abbreviated as VP. And it is freezing point is abbreviated as FP. Just one example. Freezing point of water is 0 degrees. Next. Which is the next step? Ninth one, which we discussed.
Sublimation.
Directly from solid to liquid. Solid to gas or gas to
Solid to gas, sir.
sublimation.
Sublimation.
Sublimation. Right. The process of change of physical state of a substance. Physical state of a substance. It is substance directly from
Solid to gas.
solid to gas without coming into liquid. Solid to gas. Or
Gas.
Gas to solid.
Gas to solid.
Solid to gas on heating. Gas to solid on cooling. Directly from solid to gas on heating. And or gas to solid on cooling is called sublimation. Example, you all know that when heat is given to ammonium chloride or camphor, directly they get converted to gas. And we know that the water vapors will collect in the sky and they form the cloud. So formation of the cloud is also an example for sublimation. Got it? Then, how related to sublimation? What are those? Sublime and sublimate. Sublime and sublimate. Right. Sublime and sublimate. Dhanush HK, tell the definition of sublime. No. Akshay, what are sublimes or just what is a sublime?
The object which undergoes change.
Sinchana,
The solid substance which undergoes sublimation is said to be sublime.
the substance that undergoes sublimation is called sublime. And the substance which is obtained as a result of sublimation, that is called sublimate. Right? The substance that undergoes sublimation is called sublime. Example, I write NH4Cl. What it is? Name this chemical compound.
Ammonium chloride.
Ammonium chloride.
Aluminum chloride.
Then naphthalene bonds. NaPH-THA-LeNe. Naphthalene bonds.
Camphor, sir.
Hope that you have seen the naphthalene bonds. Right?
Yes, sir.
To avoid the or to protect the cloth from moths and insects, we will go for using this white color chemical substance called naphthalene bonds.
Naphthalene
If
bond.
it is kept for some days, you can notice that after that its size will be decreased. What is the reason?
Sir, because of oxygen.
Because
Let they undergo sublimation.
Undergoes sublimation.
naphthalene bond undergoes sublimation. Directly it gets converted into gas. That is why its size is reduced. And even if you leave it for some more days, afterwards it disappears. As it undergoes sublimation completely.
Which chemical is used in naphthalene bonds?
That is one organic compound in it. I'll tell you that. Naphthalene bonds. Next, camphor. It is also one of the carbon compound. Camphor. Next, even iodine. Iodine is also is an example for sublime. These are few substances.
Ammonium chloride is also there.
Sublimation. Written up.
Sir, cloud.
I'll give you the definition of sublimation. Here on right. The substance which is obtained, go and write it, as a result of sublimation. Right. The substance which is obtained as a result of sublimation. Gaurav, have you written? Is called sublimate. Over. So these are the terms involved. Next, we are sublimate. I told you, ammonium chloride, when it is heated, it gets converted to gas. That is sublime. And when these gases are collected on the watch glass, then we will get a powdery mass, and we call the powdery mass as sublimate. Now, we are going to draw an important diagram which shows the interconversion of different states of matter. Got it? Yesterday only we had drawn that. What is that?
Triangular shape.
Which geometrical figure was drawn to show the
Triangle.
Triangle.
triangle? Right. Slide heading. Diagram to represent the interconversion of different states of matter.
Requesting everyone, please turn on your video. If you are removed, it is your responsibility. Everyone turn on your video.
Yes. Go for mark. First one is solid. Next, with some distance, you have to write liquid. The third one is gas. You know that these are the three states of matter whose interconversion is to be shown in the diagram. And these are to be considered as three vertices of a triangle. SC is one vertex, L is second vertex, and G is third vertex. Over up. Over. Then
Yes, sir.
Yes, sir.
Yes, sir.
and draw two lines from solid to liquid. The first line and this side. Draw it neatly. Similarly, liquid to gas, two lines. Next, gas to solid. Even solid to gas also. Over. Without fail, you have to show the direction. First, solid to liquid. What do you call this process?
Fusion.
Conversion from solid to liquid.
Melting.
I'll write.
Melting.
Melting. In bracket, you may write fusion. Please write with me. Next, show the direction from liquid to gas. Just I am taking only the lines which are outside. What do you call this process?
Vaporization.
Vaporization. Vaporization. Next. Gas to solid.
Sublimation.
It is called sublimation. Just I am taking the rays outside this triangle. Now I'll go for taking the rays inside. Over up. Now, what it is called?
Sublimation.
This is also sublimation. Next, gas to liquid.
Condensation.
Condensation. Next, liquid to
Solidification.
freezing or solidification. Freezing or solidification. Have you drawn? Is it completed?
Yes, sir.
Yes, sir.
Ora. Okay, stop writing. Then listen. Dear students, now we are moving to an important activity to show ammonium chloride is a supply. This experiment was also given in the examination. Question was like this. Explain the experiment with a neat level diagram to show sublimation of ammonium chloride. Sublimation of ammonium chloride. Chandana, hope that you are concentrating here. Chandana, can you hear me? Chandana, you. Can you hear me? Good girl. Okay. We are moving to the experiment to show ammonium chloride is a supply, or else to show that or to explain the sublimation of ammonium chloride. So please write this side heading as a question. Write the side heading. Explain the experiment. Explain the experiment with a neat leveled diagram. Neat leveled diagram. To show the sublimation of ammonium chloride. Ammonium chloride. In bracket you can also write to show ammonium chloride is a supply. NH4Cl is a supply. NH4Cl is a supply. Ora. Then stop writing and observe. The students, to conduct this experiment on sublimation of ammonium chloride, we need some of the materials. Do you know what are these materials? If you have read the textbook, you'll be able to tell. The materials are, one is glass funnel, watch glass, glass rod, cotton, these are, and also china dish. Then the chemical substance that we are going to use is, it is ammonium chloride.
Ammonium chloride.
Whether ammonium chloride, will it be available in crystalline form or amorphous form?
Crystals.
Crystals.
Crystal form.
It will be in crystalline form. It will be like a small particles. Amorphous form antandre, it is very soft, like a powder. Powdery mass tara irutte. It is ammonium chloride. Do you know what is the color of ammonium chloride?
Colorless, sir.
Color of ammonium chloride is white.
Color.
Color of ammonium chloride is white. So now first let us come to know how should be the arrangement of materials. Just first I'll go for explaining roughly, then afterwards you can draw with me. Now you have to listen. Please stop your activity. It is very simple. We will go for taking an iron stand, as I said. This is an iron stand. Then for this iron stand, we will go for fixing a glass funnel invertedly like this. Next, then we will go for taking the china dish. In that ammonium chloride is to be taken, and this is to be placed over wire gauze to avoid the direct heat to the china dish. We will go in between. We will go for using wire gauze. Then this arrangement is to be placed on tripod stand, 3-leg stand. Then below this we will go for placing the Bunsen burner. Amog, I told you not to go for drawing because just it is a rough diagram. I'll go for drawing neatly afterwards. Okay. Then first we will go for taking some amount of ammonium chloride, NH4Cl crystals in the china dish. Then start providing heat to the china dish containing ammonium chloride using that Bunsen burner. And you have to wait for a while. Then after some time, the fumes start coming out. As soon as the fumes are observed, immediately just place the funnel, glass funnel, invertedly to cover the ammonium chloride. Let all the amount of ammonium chloride collected on the inner wall of the glass funnel. When the fumes stop coming out, then immediately you can go for removing the Bunsen burner. Afterwards, let's see, look here. Afterwards, take a glass rod and just go for scratching the inner wall of the glass funnel using the glass rod. Then you can collect the powdery mass of ammonium chloride. And one more thing I forgot to tell you here, when you start providing the immediately,
Cotton.
most of the funnel should be closed with a cotton plug, because whatever the fumes are coming out, they should not escape from it. Followed? So the collected powdery mass is ammonium chloride. Did you understand? This is very
Yes, sir.
simple experiment. Once I repeat, listen carefully. First, I'll tell you the experimental arrangement. First, take a glass funnel, fix it to the iron stand. Second point, take some amount of ammonium chloride in the china dish and place it over wire gauze. And this arrangement should be placed on tripod stand. Next, below that, place a Bunsen burner. This is experimental arrangement. Next, procedure. Start providing heat to the china dish in which ammonium chloride is there. And it is noticed that the fumes will be coming out. As soon as the fumes are coming out, immediately close the china dish with glass funnel invertedly, which is kept invertedly, and then close the mouth of the glass funnel with cotton plug to avoid the escape of fumes. Next, continue to provide the heat till the fumes coming stop. When the fumes coming stop, then remove the Bunsen burner. Then and take out this glass funnel from the iron stand and place it for a while for cooling. Then after that, then take a glass rod and start scratching the inner wall of the glass funnel. Then powdery mass is collected in the watch glass. So here, ammonium chloride is a solid and providing heat, it gets directly converted into fumes, that is as gas. So that is why you can say that ammonium chloride is a sublime.
Then again it will convert it into powder, sir.
Yes.
Then again it will convert to solid. Powder means solid.
Thus, that powdery mass is nothing but solid only. Clear up?
Yes, sir.
The ammonium chloride, what we have taken, it is sublime. Whatever the powdery mass we have got, it is sublimate.
Yes, sir.
Right, Tala? Now, you should go on drawing with me. Take scale and pencil. Just leave about 8 to 10 lines. You have to start from it. Leave about 8 to 10 lines. First, draw a line which represents the experiment table. Alright. Look here. Here, first, I'll go for drawing China dish. China dish. One, Ganesh. It is China dish. Then draw the wire blocks. This is wire blocks. Last color of the then draw a tripod stand. Next, draw Bunsen burner. Next, draw the funnel, glass funnel. And drawn like this. Next, draw an iron stand. And here you have to show the cotton plant. होगा ना? Next. Copy that quickly. Meanwhile, just let me show you the materials required. Please observe here. Can you tell what is this?
Stand.
Tripod stand.
Tripod.
Stand.
It is tripod stand. Next, see that. This is
China dish.
China dish.
it is China dish. What has been taken?
Ammonium chloride.
Ammonium chloride. And could you tell what it is?
Mesh.
This is
Mesh.
Wire gauze.
Wire gauze. Wire
it is
gauze.
wire gauze. See that the arrangement should be like this. Look here. This is it is the arrangement. Next, hope that you have seen the funnel. Have you seen the glass funnel?
Yes, sir.
Yes, sir.
This is glass funnel. And look here. It should be placed like this. Now let me show you the whole arrangement except iron stand. I'm showing the remaining. This is the arrangement.
Sir, the glass will not break, sir, for the fumes.
No. That is why we are providing the heat. We have avoided to give the heat directly. For that purpose only we are using the wire gauze.
Yes, sir.
Hope that you have finished.
Yes, sir.
Let's go for leveling. Go on writing with me. Don't take much time. Right. Could you tell what it is?
Glass funnel.
Cotton.
It is cotton plug. This cotton is used as a plug to avoid the escape of fumes of ammonium chloride. Right. Cotton plug, PLUG. And could you tell what it is? Manya
Glass
Chetan?
funnel.
Funnel.
Glass funnel. Glass funnel.
Inverted funnel.
Glass funnel. Next. Manya J. Chai.
Yes, sir. Metal stand.
Metal stand
Metal stand.
or
Wire gauze.
holder.
Right. Iron stand. Next. What are these?
Mention, sir. Glass.
Ammonium vapor.
With green color I am sure.
Ammonium vapors.
Ammonium vapors.
Ammonium chloride, not ammonium, just ammonium chloride vapors or fumes.
China dish.
Yes, it is
China dish.
China dish. Then it is not transparent, just I am showing you this. Could you tell what it is?
Ammonium chloride.
Crystal.
Ammonium chloride.
Ammonium fumes.
NH4Cl crystals. Ammonium chloride crystals. Next. Tell this.
Wire gauze.
Wire gauze.
Next.
Tripod stand.
Tripod stand. Tripod stand. This is
Bunsen burner.
Bunsen burner. And don't read it as Bunsen burner. It's Bunsen burner. This line, this horizontal line indicates the experiment table.
Sir, what is last one, sir?
Bunsen burner, B-U-N-S-E-N. Now, let me give you the procedure and right.
Sir, it is compulsory to use tripod stand, sir.
Usually in the lab, we will go for that.
Okay, sir.
Right. Procedure. First point. Are you all writing with me?
Yes, sir.
Yes, sir.
Yes, sir. What is the first point? Take some amount of ammonium chloride crystal in a China dish. Right. Take some amount of ammonium chloride crystals. Ammonium chloride crystals in China dish. Hola. Next.
Yes, sir.
Place it on.
Next day.
Cover it with a glass panel.
Cover with a glass panel.
Place the glass
Place
funnel
the funnel on
with
top.
Place the funnel with the help of iron stand.
ammonium chloride crystals. Right. Place the glass funnel inwardly to cover ammonium chloride crystals. Ammonium chloride crystals. Next. Close the mouth of the glass funnel with cotton plug. Close the end of the funnel. End of the funnel with cotton plug. Cotton plug. Next.
Sir, after take some what, so that
Take some amount of ammonium chloride crystals in a China dish. Then place the glass funnel inwardly to cover ammonium chloride crystals taken in the China dish. Next, close the end of the funnel with cotton plug. Now, right. Heat the China dish. China dish slowly. When heat is being given, what will be your observation? It is observed
It is observed that Ammonium release fumes.
Ammonia results in
converts into
The
vapor.
white fumes will be coming out from the China dish. They are the fumes of nothing but vapors of ammonium chloride. Right. It is. Observe that. Observe that. White fumes coming out. Coming out from the China dish. Directly we can write the conclusion. What is the conclusion? Here, ammonium chloride is directly converted into gas. Therefore, we can say that ammonium chloride is a sulfide. That's all. Here, ammonium chloride crystals. Ammonium chloride crystals directly converted into fumes on heating. Hence, ammonium chloride is a sulfide.
Sir, what is the second line, last point? Second line.
Here, ammonium chloride crystals directly converted into fumes on heating. Since we can conclude that ammonium chloride is a sublime. But if you want to continue this experiment like this, okay, when the fumes of ammonium chloride stop coming out, then remove the Bunsen burner. Next. Take the trial Bunsen. Look here, look here. Take out this glass funnel from the iron stand and place it on the watch glass for cooling. Then after some time, take a glass rod and scratch the inner wall of the glass funnel. Then we get a powdery mass of ammonium chloride. If you want to show that in the diagram only, you can include that. So this is watch glass. This is watch glass, and here I am drawing the funnel. This is funnel.
Sir, on the diagram.
This is ammonium chloride, and you go for scratching it by using the glass rod, funnel, watch glass. Then powdery mass of ammonium chloride is correct.
Sir, we have to write beside of the diagram only, sir.
Shall I rub it?
Sir, once say that last third point.
This is that. Is this?
No, sir, it is observed that while.
It is observed that white fumes of ammonium chloride coming out from the China dish. You want to include the words white fumes of ammonium chloride coming out from the China dish. Then here ammonium chloride crystals directly converted into fumes on heating. Hence ammonium chloride is a sublime. Shall I repeat?
Yes, sir.
No, sir. Don't rub the
Sir, finished.
procedure.
Finish the
Diagram finished, sir.
Sir, rub over, sir.
diagram over, sir.
Joy.
So that sir, what is the last thing?
Important activity. Look here. In this activity, we will go for taking glass beaker. In that, some pieces of ice cubes are taken. Manya Chejai? Are you fine? Okay, good. Just look at it. Observe it. Here we are taking a glass beaker. Then in that, some pieces of ice cubes are taken. And this glass beaker is to be placed down. What it is? Wire gauze.
Where goes?
Placed over. What it is?
Tripod stand.
Tripod stand.
Proper placing.
Bunsen burner.
Next, and even you will take
Iron stand.
iron stand for the
Sir, we
ice.
should draw.
We will go for fixing.
Sir, we should draw now, sir.
Glass.
Measuring the temperature. What is that?
Thermometer.
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 Thermometer. It is thermometer.
Sir, we should draw, sir.
To remember the bulb of the thermometer, it should be just inside. Okay, it should be covered in the ice cube. Now you look at that temperature of this ice cube. What may be the temperature?
0 degrees.
0 degrees.
0 degrees Celsius.
It is at 0 degrees Celsius, even less than that also. Maybe minus 2 degrees Celsius,
Minus 25
1
degrees.
degree, minus 3 degrees. Let us assume that it is at minus 3 degrees Celsius. It is just our assumption only. Now, let us start providing the heat to the beaker
By
containing
Bunsen burner.
the ice cubes. Using the Bunsen burner, we are providing the heat very slowly. Very small amount of heat is being given. So then observe the level in mercury level in the thermometer. What happens? It will go on increase.
Decreasing.
It will come to minus 2 degrees Celsius. It comes to
Minus 1 degree Celsius.
Yes, it comes to 0
Degree Celsius.
No.
Plus 1 degree Celsius.
When you keep observing, you will come to know that when it reaches to 0 degrees Celsius, afterwards there will be no change in the temperature. But at the same time, you can also notice that these ice cubes start melting. Got it? Then you all will be thinking that when heat is given to a body, obviously the temperature will go on increasing. When it reaches to when it reaches to 0 degrees Celsius, there will be no rise in the temperature. Then where the provided heat has gone,
It is absorbed by solid, sir.
yeah, it is the amount of heat. See, whatever the amount of heat we are giving after 0 degrees Celsius, this amount of heat is utilized to convert ice cube into water, liquid. Okay. Then what are the amount of heat that we are going to use for converting the whole ice cube into water? Nothing but the whole solid into liquid. And
Latent
we
heat.
call
Latent
this
heat.
amount of heat as
Latent heat.
hidden heat, and which is also known as latent heat.
Latent heat.
Did you all understand?
Yes, sir.
Yes, sir.
Latent heat, it is a hidden heat. Okay, you know, when it is at -3 degrees Celsius, or when we are providing the heat, the temperature will go on increasing, so that you can say that heat is being utilized for increasing the temperature. But when it reaches to 0 degrees Celsius, then afterwards there will be no rise of temperature, which means that the provided heat afterwards, whatever the amount of heat we are giving, this heat is being utilized for converting this solid into liquid, that is ice cubes into water. So this, the heat required for converting one state to another state, we call it as latent heat or hidden heat. Even for to understand this, we have one more activity related to this only. Okay. Again, assume that the whole ice cube converted into water. This is a beaker now in which melted ice cubes, nothing but it is water.
Water. Liquid water.
And let us go for placing it on
Iron
Iron bar.
tripod stand.
Tripod stand.
Bunsen burner.
Bunsen burner.
Bunsen burner.
Iron
Iron stand.
Iron stand.
With support of it.
to suspend
Iron stand.
Thermometer.
Holder. Holder.
the thermometer. Now let the bulb of the thermometer, it should be just to below the surface of water. What is?
Water.
When it is dipped completely, the heat will be added to this glass also. What is? That is why only the just bulb of the thermometer, it should be just inside the water. Now let us come to know the temperature of this water.
0 degrees Celsius.
30
degree.
50 degrees.
30 degrees.
60
30 normal water will be
25 degrees Celsius. Room temperature.
25 to
Usually
27.
room temperature ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಲ್ವಾ? So assume that room temperature is about 25 degrees, as Jacknor said. This is the water which is at 25 degrees Celsius. Now let us provide heat to the beaker containing water. What is your observation in the level of mercury?
Sir, it
It
increases.
increases.
It will increase.
Increases.
Increases alva. So 25 degree irodu 30 agutte, then 35, 40 and 50, 60, 70
Up to 100.
When it comes to 100 degrees Celsius, you can see the bubble
Start to vaporize.
Boiling.
So we can say that the water is being boiled.
Phenomena.
When it reaches to 100 degrees Celsius, think that still you are providing the heat. Will there be any change in the temperature?
No, sir.
No, sir.
There will be. When it reaches to 100 degrees Celsius, there will be no change in the temperature.
Temperature. Because the boiling point of water is 100 degrees Celsius.
Wait. Whatever the amount of heat which is being given after 100 degrees Celsius, this amount of heat is utilizing for converting this water into
Water vapor.
Water vapors.
Vapors.
Water vapors.
liquid. Steam is the gas. So the amount of heat which is being given after 100 degrees Celsius is utilized for converting liquid into gas. So this heat, it is hidden. hidden ಯಾಕೆ ಅಂತ ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ there is
Then are latent.
for providing heat alwa ಮುಂಚೆ ಅಂತಂದ್ರೆ when we are providing the heat as a result of it temperature is being raised. If temperature rise agide andre you can think that heat is being given. But here when it reaches to 100 degrees Celsius there is no rise in the temperature and that the heat which is giving after that is it is hidden and we call this hidden heat as latent heat. Now we can define the latent heat like this. The amount of heat which is required or which is used to convert the physical state of a substance of 1 kg from one state to another state is called latent heat.
Sir, tell again, sir.
One second. The amount of heat required to change the physical state of a substance of 1 kg from one state to another state is called latent heat. Got it? And here the 1 kg of a substance that we have taken is solid. Solid is being converted into liquid here. So that is why this latent heat is known as latent heat of melting.
Latent heat of fusion.
Next, here the amount of heat required to convert the physical state of a substance from liquid to gas.
100 degree.
Boiling point.
Boiling.
This is called latent heat of vaporization. These are the two types of latent heat. One is latent heat of melting, latent heat of
Vaporization.
During this conversion, will there be any change in the temperature?
No, sir.
No, sir.
Change ಆಗ್ತಿಲ್ಲ.
No, sir.
Temperature will be not changing.
Once again, I'm going to give you the definition. Listen here. Ranjana Pisale. Ranjan, once I tell that. The amount of heat required to change the physical state of a substance of 1 kg from one state to another state without rising its temperature is known as latent heat. There are two types of latent heat. What are those? Yeah.
Vaporization.
Latent heat of melting, latent heat of vaporization. If you know the definition of latent heat, it is very easy to define both. Latent heat of melting it. The amount of heat required to change the physical state of a substance of 1 kg from solid to liquid at its melting is called latent heat of melting or latent heat of fusion.
Sir, unwanted disturbance.
Unwanted disturbance, sir. There is unwanted sound.
Prashant sir, you take care. Nothing to it, just concentrate. Here, the amount of heat required to change the physical state of a substance of 1 kg from liquid to gas at its boiling point.
Boiling point.
Latent heat of vaporization. Clear up? Listen. So, in 1 kg and usually whatever the amount of substance can be taken, it is to be the amount of heat given is to be calculated for unit mass. 10 kg idu kuda adu 1 kg ge tagthu ಎಷ್ಟು amount of heat na ನಾವು ಯೂಸ್ ಮಾಡಿದ್ವಿ ಅಂತ for converting 1 kg to 1 kg from one state to another state. Got it? If so, dear students, could you tell the physical quantities on which latent heat depends?
Temperature.
Temperature.
Definition case one. The amount of heat required to change the physical state of a substance of 1 kg from one state to another state without rising its temperature. First, you identify the physical quantities that are involved.
So
Sanjana,
temperature and mass.
Heat.
Heat, sir.
Heat, sir.
Heat.
Mass.
Very good.
Heat and mass.
It is
Mass
heat.
and volume.
Next.
Mass.
Mass.
Volume. Volume. Temperature.
These are the three physical quantities that are involved in the definition. Here we will go for taking the latent heat as the heat required to convert 1 kg of a substance. I mean 1 kg per it is mass.
Sir, if we take liquid, how it will come 1 kg, sir? Sir, if we take liquid, how it will come 1 kg?
Liquid 1 liter.
Sir, liquid 1 liter will come now, sir.
Please do remember, this is an important point for water. Water, we can go for using 1 kg along with liter also. 1 kg, because 1 liter of water is equal to 1 kg. But for oils and all, it is not true. For water is the only liquid for which we will go for using this. You may go for using 1 kg of water. No wrong in that. But don't tell this to public. They won't accept. You shopping over to give 1 kg of water andre avaru kodalla. Bere kodtare avaru. Got it? There you should ask only 1 liter water. But you must have the knowledge that 1 liter of water is equal to 1 kg. Hence, there is nothing wrong in saying that 1 kg of water instead of 1 liter of water. So now let me write the formula that we used to find out latent heat, mass and heat. Latent heat is equal to mass of a substance which is to be converted, whether it may be solid or liquid. Mass of a substance then divided by
We can copy, sir.
quantity of heat. It is equal to, symbolically it can be written as latent heat is denoted by L. Mass of a substance is
M by
denoted by
H.
M by Q.
M by H.
Q.
Quantity of heat,
Quantity.
it is Q. L is equal to
Sir, we should write
M
sir.
by Q.
M by Q.
Sir, we should copy that, sir.
I will make you to write. You ಏನು worry ಮಾಡಕ್ಕೆ ಹೋಗಬೇಡಿ, ನಾನೇ ಎಲ್ಲ ಬರೆಸ್ತೀನಿ. This is the formula used to find out latent heat. One simple question to all students. Let me tell how many of, let us come to know who will go for telling the answer. The question is, anybody want to tell the SI unit of latent
kg joules.
Joules per
kg joule.
kg joule.
kg per joule.
kg joules.
Per joule.
enough?
kg per joule.
joules per kg.
kg per joule.
kg per joule.
kg by joule.
Those who are understanding English, please stop. If not, continue. Fortunate. I am very fortunate. Jackno, tell the SI unit.
Sir, kg per joules.
kg per joule.
Joules per kg, sir.
Joules per kg.
Joules kilogram.
Then you started. Wait. I am going to discuss with Jackno only. Jackno, how did you tell that?
Sir, mass SI unit is kg, sir.
Excellent.
Heat SI unit is joule, sir. So kg by joule.
Very good. Definitely you are right. Just I checked your confidence level. You are very confident about your answer. I appreciate you. Look here. SI unit of mass is kilogram. Then per SI unit of quantity of heat in general, heat, it is joule. And This symbolically it can be written as kg per joule or kg J inverse. Many of you will read like this kg per joule. ಅಂದ್ರೆ ಒಂದು ಸಿಂಬಲ್ ಅಲ್ಲಿ ಹೇಳೋದು ಇನ್ನೊಂದು ವರ್ಡ್ ಅಲ್ಲಿ ಹೇಳೋದು. Either you should tell both in words or both in symbol. ಹಂಗೆ ಹೇಳ್ಬೇಕು ನೀವು. Kilogram per joule. It is correct. Kg per J. This is correct. Not kg per joule. Or else kilogram per J. They are all wrong. Wrong usage. Got it? Jagnur, both
Yes, sir.
you have understood this. It is kilogram per joule or kg J inverse. Now you will write about latent heat. Yeah, please write side heading. Side heading. Latent heat. Dictate ಮಾಡ್ತೀನಿ ಬರ್ದು ಬಿಡಿ ನೋಡೋಣ. Shall I tell now?
Yes, sir. Yes, sir.
Okay, right. The quantity of heat. Side heading, you have written latent heat. Gaurav ಬರೀತಿದೇನಪ್ಪ? ಈಗ ನಾನು ಹೇಳೋದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ನಾನು ಸ್ಲೋಗೆ ಹೇಳ್ತೀನಿ. ಕರೆಕ್ಟ್ ಆಗಿ ಬರೀತಾ ಹೋಗ್ಬೇಕು. The quantity of heat required. The quantity of heat required.
Yes, sir.
To change. To change 1 kg of a substance, to change or to convert, to change 1 kg of a substance from one state to another state. One state to another state. Hope that you can understand. Not Karnataka and Andhra, Telangana. One state to another state means one physical state to another
physical state.
One state to another state without rising its temperature. Without rising its temperature. Lakshmi Shri, have you written? Oh, very good. She has already written the definition. The amount of heat required to change the physical state of a substance of 1 kg from one state to another state without rising its temperature is called latent heat. The amount of heat required to convert 1 kg of a substance from one state to another state without rising its temperature, or without changing its temperature, is called latent heat. Just below formula. 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 Write the word formula. Then below that, Viva. Let your concentration be here. Right now, latent heat is equal to mass of a substance. Gaurav, ಹೇಳಿದ ತಕ್ಷಣ ಬರೀಬೇಕಪ್ಪ. Don't go for using much time. Latent heat is equal to mass of a substance by quantity of heat. Mass of a substance divided by quantity of heat. Write its symbolic representation. L is equal to M by Q. L equal to M by Q. Below that, right side. SI unit. How do you read SI unit of latent heat?
Kilogram per
joule or kg per J. Kg per J.
Per joule. Kilogram per joule. Or
kg per J.
kg by J.
kg per J or kg J inverse J power minus 1.
kg J minus 1.
Sir, then why it is read
Thank you,
joule
sir.
per kilogram, sir?
Yes, sir, it is given in textbook like joule per kilogram, sir.
Yeah, wait. Amount of heat required. Sorry, then formula ತಪ್ಪಾಯ್ತು ಅಂತ ಅನ್ಸುತ್ತೆ. Just 1 minute and clarify. Latent heat.
Sir, latent heat is equal to heat by mass, sir.
Latent heat is equal to quantity of heat by mass of substance.
ಉಲ್ಟಾ ಆಗ್ಬಿಡ್ತಲ್ಲ. One minute, I'll clarify. Right. It is. Istu reverse ಬರ್ಕೋಬೇಕು. It is.
Sir, we can scratch the
Quantity of
answer,
heat
sir.
divided by mass. Tomorrow myself only will write this. Now you just go for striking it out. Tomorrow I'll give you the points from here. Yes.
Sir, is light is a matter, sir? Light is a matter, sir.
Light,
Light, sir, light GT.
light, it is just energy.
It is a form of
an
energy.
ಈಗ SI ಯೂನಿಟ್ ಅದೇನು ಬರೆಯೋದಕ್ಕೆ ಹೋಗಬೇಡಿ. Just tomorrow I'll teach you this in detail. From formula I'll give you that. Just the definition is enough. Definition
is correct, sir.
Definition is correct, no problem at all. Okay. Now it is time up. I'm going to stop that. And please do practice whatever the concepts we have taught today.
Yes,
And
sir.
yesterday's worksheet and today's worksheet, both will be given together.
Yes, sir.
Yes, sir.
Tomorrow, let me continue the same chapter. With this,
Yes,
let us
sir.
stop the
Yes,
class.
sir.
Thank you very much.
Thank you,
Thank
sir.
Thank you,
Bye,
sir.
sir.
Thank you, sir.